Now we're going to dive into another example of creating a simple machine learning model. This time we're going to focus on using a different data set, the ASHRAE Global Thermal Comfort Database 2. And we're going to focus on a different objective, which is classification instead of regression. So if you go into the code for this data set, there's going to be a notebook called Supervised Classification Models Example. I have that here already up and running, but you will need to copy this into your Kaggle account and create your own versions that you can follow along and execute it one chunk at a time. We'll go ahead and get started. The first thing we'll do is go ahead and run and load the different libraries that you'll need, which include pandas, matplotlib, seaborn, and then of course quite a few of the scikit-learn functions, which will load in this way. We're going to look at this indoor environmental quality data set of the ASHRAE Global Thermal Comfort Database. You'll notice over here that the database itself is here. The file path we load it using is like that. When we load it, what we end up with, if we look at the .head, the first 5 rows, is you've got quite a few column names, and then each of those columns is an attribute of a person who's left feedback in a certain context according to the research experiments that are contained in this data set. If we look at it from the .info perspective, there is over 100,000 of these entries. There's 70 columns describing these 100,000 rows, and you've got all different kinds of data to support this. If you look at the non-null count for each of these rows, some of them are very complete. So things like data contributor, year, season looks like perfectly complete except for a few missing entries. And then you have columns like air movement acceptability, which is much lower, only 16,000 out of 100,000. We're going to take a look at a subset of this data to classify, to predict thermal sensation. Thermal sensation is, as if you might remember from previous sections, a 7-point scale, and from -3 to +3. So in 0 in between, 0 means that you're thermally neutral. You don't really feel anything. +3 means you're very, very warm, and -3 very cold, and then basically everything in between. One of the things we want to do is make thermal sensation a category. And how we do that is we round it into the nearest whole number. Here you can see once we do that, we have a new column called thermal sensation rounded. We have 0 being the most common, so thermally neutral, a little bit warm or a little bit cold. So we have like a bell curve almost around the 0 point, and very warm or very cold are the most rare ones. And what we're going to do is predict thermal sensation as a category. So predict one of these 7 classes using some of the other columns from the data set. And to do that, we will use a random forest model, which is something that is a little bit more advanced than what we had before with the nearest neighbor regression. This will be a model that is going to have other features which we'll learn about as we go through this. To do this, if you remember last time, we created train test data sets based on regression, with the training data and the regression data being the following month. In this case, we need to create a data set which is some mix of the rows in this data set, where order doesn't really matter. If we look at the first 5 rows again, you'll notice that each of these is a person, that data contributors is the researcher, but each of these is a person that's exposed to various conditions and gives a thermal comfort strategy. If we look at the list of columns here, there's a lot of columns we can choose from. We know that thermal sensation rounded is going to be our target objective to predict. But what are the features that we want to use for that prediction? What are we going to use for training data? And so I went through and went ahead and decided, okay, let's try to use a little bit of information about the context, the country, the city, the environmental conditions, some of the personal factors, not all of them, and came up with a list like this. And this is the columns that we're going to use for the modeling process, which include basically the top ones are all going to be input features. And then of course, we're going to include the target variable itself. If we create those columns, we can create a new data set, IEQ data 4ML, which includes only those columns. We end up with a little bit smaller of a data set in terms of the columns that are involved, but we still have 100,000 of these rows. You'll notice that, for example, sex is a column that has 67,000 non-null values. So not all of these columns, not every row in this data set has all of the data points. What we need to do in order to train a model, in this case, we could fill those gaps. There's various ways to do that, which you'll learn in future sections. But for simplicity's sake, we'll go ahead and just drop the rows that don't have complete data in all of these columns. So that's relatively straightforward with the drop NA function. And then what we end up with is a new data frame where every single row has a value. So there's 43,835 of these rows that we can use for this model without any missing values. This is a complete data set. And you'll notice that you have both float 64 values for some of the features, as well as objects or strings or categories for certain features. We will drop out our objective variable, thermal sensation rounded, and create a new data set called features. If we look at that features, it's basically exactly the same as what we had before, except we've dropped our objective feature. The target in this case, let's create its own little data frame, is thermal sensation rounded. So if we go ahead and create that variable target, and we can notice from .head here that we have not a data frame, but a data series, which is one-dimensional, which has these values of either 0, 1 plus 1, 2, 3, or minus 1, 2, 3. So 7 different categories that we can choose from. The next step we want to do before we build the model is create dummy variables for the categories. We can just simply use the getDummies function, which one-hot encodes automatically the categorical variables. And it does, this is a pandas function, which is really handy to do. Now we have a features with dummies. So it's been transformed. It's been one-hot encoded to create all the categorical variables. And if we do .info, we can see that now we have 100 columns of features, as opposed to just up here, we've only got 13 columns, because each of the categorical variables was transformed in a way that makes it numerical value instead of a categorical value. So in the next video, we'll go ahead and dive into doing that train test split and creating the model and evaluating the performance of that model.